Good afternoon, viewers. We'll be solving another beam that is going to be a little bit complex compared to the previous ones we have solved. This is the question. A simply supported beam carrying 2-point loads, a UDL, and couple moment from the left side, 2 kilonewton of 2 meter, 3 kilonewton meter of 6 meter positive couple moment, and 5 kilonewton of 9 meter with a UDL of 6 kilonewton per meter of 4 meters from 9 meter. Total length of 13 meter. The question is A. Find RA and RB. B. Calculate the shear force. C. Calculate the bending moment. And D. Draw the shear force and bending moment diagram. This is the question. The challenge now is to be able to produce the diagram indicating the beam. So now, for instance, for this diagram now, look at the accurate aspect of it, which is the beam is having a pin and roller. So you need to draw the free body diagram to indicate all the forces and the moment. This is the free body diagram of the beam. So you can see the HA and the RA and the moments in clockwise manner, which is positive and negative. This is the free body diagram. Now, the first thing according to our question is to find RA and RB. So this is how to go about finding RA and RB, which is taking moment at point A equals to 0. So we will be considering all the loads with respect to either point load or UDL or couple moment. So now for the first one, if you are taking moment at point A equals to 0, so if you come to point C, the distance from point C to our point of moment is 2 meters. So automatically it means we are going clockwise, which is 2 times 2 to give us 4. Then plus the couple moment is in negative form, so automatically it is 3 kilonewton meter. So you are not multiplying it with any distance. So you pick up the 3 kilonewton meter by saying plus 3 because it is in the direction of the positive. Then the next load is point E, which is 5 kilonewton. So the distance from where it is acting to point A is 3 plus 4, 7 plus 2, which is 9. So it's going to be 5 times 9. Then plus the UDL, which is uniformly distributed load. At first, you have to convert it to point load by saying plus 6 times 4. Then it will act at the midspan, which is 6 times from midspan to point where we are taking a moment is 11, which is 2 plus 3, which is 6 plus 4, 2 plus 3, which is 5 rather, plus 4, which is 9, 10, 11. So the point load, which is 6 times 4 multiplied by 11. Then at point B is a negative moment, which is negative RB times the total length, which is 13, equals to 0. If you do it mathematically, you'll be having your RB equals to 24.31 kilonewton. Watch my previous video, you will see this particular reaction. RB equals to 24.31 kilonewton. So now the same thing with taking moment at point B, you will have your RA as 6.69 kilonewton. Then if you do the summation of vertical force equals to 0, you compare, you have your final answer as 31. So now our first question has been answered, which is to find RA and RB. Our RB is 24.31 kilonewton and our RA is 6.69 kilonewton. So now we are to calculate our shear force from our respective reactions. So now to calculate the shear force, our RA, which is this point, is 6.69 kilonewton. So our shear force at this point is going to be that RA, because shear force is the force at that point. So if our shear force at point A is the reaction at point A, so automatically our shear force at point A equals to the reaction. Now shear force at point C, which is the same force from that point, because we have not past that particular point, so we have the same shear force, so automatically it is 6.69 kilonewton. So now shear force at point D, now we have A to C, because we have not crossed D, so automatically we have it as 6.69 minus 2. If you look at it very well, you understand 6.69 minus 2 equals to 4.69 kilonewton. That is the shear force at point D. Now at point E, we will still have the same shear force, which is 4.69 kilonewton, because we have not approached that point. So look at it critically. So now at the last point, which is point B, that is where we have to look at it critically. So now shear force at point A, remember, is 6.69, and then at this point, so it will be 6.69 minus 2, which is this one, point load, minus 5, which is our point load, minus, we'll convert this to point load, 6 times 4, then plus our reaction at point B will give us the shear force 0. If it is not 0, you are wrong. So now the question is, why didn't we include our couple moment? Couple moment is moment on its own, is 3 kilonewton meter, so we are not including it when calculating our shear force. So now we have answered the B part. Now the C part is calculate the bending moment values. So now you have to understand there are techniques when dealing with bending moment values within the UDL. So we will be using WX squared over 2 as our point of reference for the UDL. So now for bending moment, we'll be having our point at point 0, or point A is 0. What is bending moment at that point? Is the moment at which the distance multiplied by the length. So we have a particular reaction at that point, which is 6.69 times 0, because the distance is 0. So automatically we have bending moment at that point, or bending moment at 0. Then at point C, we'll shift, so automatically we have it at 0. So now from that point is 2 meters. So if it is 2 meters, that is our RA, which is 6.69 times 2, gives us 13.38 kilonewton meter. Remember, the unit is kilonewton meter, while shear force is kilonewton. So now at point D, we will be having 2 moments because of the couple moments. We will have when we include the 3 and when we are going to exclude the 3. So bending moment at point D without the couple moment is going to be 6.69 times 6. Why is it 6? Because from that point to D is 6. So we are multiplying it by 6. Then minus, why is it minus? Because the load before this D, which is C, is coming down. That is why it is minus. So 2, which is the force, multiplied by the distance from C to D is 4. That is why we are multiplying it. So when you do it mathematically, you'll be having it as 32.14 kilonewton. If you check, we are not including our couple moment. So now the next point is to include the couple moment, which is 6.69 times 6 minus 2 times 4 plus the couple moment. That is the difference between the first point, which is D, and the second point, which is D. So we'll be having it as 35.14 kilonewton meter. So the changes will be reflected in the bending moment diagram. So now at the last point, which is point E, or second to the last point, point E, 6.69 times 9. Why is it 9? You look at the point E, from here to here is 9. 2 plus this is 6 plus 3, 9. That is why it is 9. So minus, which is this one, times from C to this particular point is 7. That is why we're multiplying by 7, plus our couple moment 3. Why is it plus? Because it is in the direction of the positive, equals to 49.21 kilonewton meter. So let's take the last point. We'll be very careful when taking the last point because it's supposed to give us 0. So now it's going to be 6.69 times 13. 13 is the total distance, minus 2 times 11. How did you get 11? 4 plus 3, 7 plus 4, that is 11, minus 5, which is the one coming down, times 4. From here to here is 4, minus, remember our original equation when I explained the diagram. So now the original equation is WX squared over 2, so we'll be using it our W is the load, which is 6 times the length. The length is 4 square over 2. So when we do it mathematically, we have our bending moment as 0. So this sign that it is 0 and the beginning that it is 0 shows that it is correct. Now to draw our bending moment diagram, we will sketch the beam and then trace out this line and then use all the respective values of our shear force and all the respective value of our bending moment to draw it. So now at A for the shear force, remember it's 6.69. Remember to write your unit so that you will not write the unit within the diagram again. So when you draw it positively 6.69, then you draw it in a linear way, because from here to here there is no load acting. 2 will bring it down, which is 4.69, and then straight forward, and then couple moment is not affected because it is moment on its own. So now you pull it down, then here is UDL, so it affects it in a slander form. Remember to use your values, and then you have your shear force diagram. So for the bending moment, you use your values too. Then you take your value at this point, you have it as 13. At this point, which is the couple moment, you have it as 2. Remember the first one is 32 and the second one is 35. Remember we did it twice. Then the last one is 49.21. So you trace a line to this point, trace a line, then trace a straight line, then trace this. Why is this one curved and this one straight? This one is UDL, that is why it is curved. So you have to draw it in a curved manner. But for the point load, you have to draw it as a straight line. So thank you very much, and so remember to subscribe to my YouTube. Thank you and bye.